The next topic of discussion is elastic limit. Whenever the magnitude of the deforming force crosses a certain maximum limit called the elastic limit, what happens that the body does not completely regains its original configuration, but acquires a permanent set of permanent deformation. For example, if we take this body, right, and if we start applying force, suppose we are applying F1, F1 force. We are applying F1 force. So if we are applying F1 force and if we withdraw this force, now if we withdraw due to this force, what happened is that the configuration of the body becomes like this. Now we withdraw this force. We are withdrawing this force. If we withdraw, we are withdrawing F. Then the body again regains its original shape. Now if we increase the force, suppose we are giving F2 force a little greater than F1. We are giving a force F1, F2, which is greater than F1, F2, which is greater than F1, F2, greater than F1. Again, what happens? There is a deformation. There is a deformation. But when we withdraw this force, when we withdraw F2 force, what happens again? That this body again regains its configuration. Now we slightly increase the force. Now we are giving F3 instead of F2. F3 is greater than F2. So when we give a force F3, what happens? That this body again acquires a deformation. What happens is that now if we withdraw this F3 force, the body does not regain its original configuration permanently. What happens that this body has actually get deformed and it has become like this. It has become like this black one. So originally the body was this yellow one. Now after when the deforming force was present, it was like the green one, and when the the deforming force was withdrawn, that the body has now become like the black one. So what happens is that the body, when the application of F3 means a certain force, right? Certain maximum force. When that force is applied, the body will never regain its original configuration, right? It will develop a permanent deformation or permanent set. That maximum value of force is known as the elastic limit, right? So that is why I told you, that is why steel is more elastic than rubber, because the elastic limit of steel is more than the elastic limit of rubber. For example, if you give 10 Newton of force to a rubber, it will break. But if you give 10 Newton of force to steel, it will neither deform, right? It will neither deform nor develop a permanent set. So steel is more elastic than rubber. The deformation of an elastic body, the deformation of an elastic body is directly proportional to the applied force. Which means more the force you give, more will be the deformation of the body. Within the elastic limit, elastic limit we have discussed in just now, just before this. So the deformation of an elastic body is directly proportional to the applied force within the elastic limit. So if you are applying a force which is within the elastic limit of a body, then the more force you apply, more will be the deformation. For example, if I draw the diagram, suppose this is the diagram, and here we have the force which we are applying, and here is the deformation. Deformation I'm writing with delta L. So more you give the force, there will be more the deformation, but it should be within the elastic limit. This is the elastic limit. This is the elastic limit. This is the elastic limit. If you go beyond this, then this law is not valid. Then this law is not valid. Until this elastic limit, the more force you give, more will be the deformation. So we can write within the elastic limit, F is directly proportional to del L, where del L is the deformation. Del L is the deformation, maybe we are considering the length of the body. So del L is the deformation, change in the length of the body. So F proportional to del L, or F is equal to some constant K into del L, some constant K into del L. Now, this is the force that you are applying, but according to Newton's laws of Newton's third law of motion, there will be another force within the body, and that force is known as the elastic force, which is developed within the body, and that will be opposing this. So F elastic force which is developed within the body is equal to minus F, the deforming force that you are giving. So Fe will be equal to minus K into del L, minus K into del L, and this K is known as the force constant. This K is known as the force constant. Very important term, you will require this also in simple harmonic motion. Force constant. Force constant, right, is equal to F by del L. Magnitude is F by del L.